So, hi everyone, I'm Yunpeng from DER, and now I'm going to present our work, which was conducted together with our project partner, Iman and Johan from VTI, and also with Laura and me. So, actually, as we know, autonomous vehicles has been actually seen as one of the key solutions for improving future traffic and mobility system. So, but many aspects are still needed to be further investigated. For example, influence on mobility system, safety, and vulnerable road users, and also technical and legislative issues, and also vehicle capacity, and so on. So our focus in here in our work is to investigate it and try to find out the influence of automated shuttles on pedestrians and bicycles, especially under the situation that automated shuttles and bikes, they share the same space. And we also want to evaluate the quality of trajectory data extracted from video according to different data sources. So at the end, in addition, we also want to use this result that we found as a reference to examine the modeled behavior in the simulation and try to choose the proper parameter setting in the simulation. So for carrying out our work, data was collected from the test site Linköping, which locates on the Linköping University campus. It is a part of the Swedish twin mega site in the European project show. And the shuttles operate as a public transport services in a mixed traffic environment without exclusive lanes. And the maximum allowed speed for shuttles is around 40 kilometers per hour. So the shuttles runs in clockwise direction, as you can see here, the orange line, and they serve 8 stops indicated as the red points here. So except for the eastern part, the shuttles run on common roads, mainly for vehicles. And the eastern part is more or less a shared area. That means the shuttles run on the bike path, which locates in the middle of the area. And the pedestrian can actually cross the bike path anytime if necessary. So in order to conduct different scenarios, we also built the basic simulation with Sumo and OSM. And here on the right-hand side, you can see the overview about the simulation network. So the data collection was carried out for 5 days in September 2021. As I mentioned before, we wanted to evaluate the quality of the video-based trajectory according to different data sources. So here we used 3 different tools to collect the data. The first one is the Viscondo system, which consists of 2 cameras to track object movements. And each track the road user's trajectories, speeds, and types are available. And the picture on the right-hand side here, you can see that it shows the coverage area from these 2 cameras. And the picture on the left side provides the observation views of the cameras. So now then you can have a better idea how it looks like. And then the second one is the Telraam, which should be probably known by some of you or most of you. I think it is camera-based traffic counter where speed can be estimated and traffic count speeds are classified by different road users. It was installed actually here on the first floor of this building, B Huset, facing the study area. And then the last one is the shuttle onboard device, which collects shuttles trajectories and operation conditions such as door status, battery status, driving mode, and so on. And this data was used as a ground truth reference. for the data analysis. And the collected data was firstly cleaned due to misclassification, ghost trajectories, for example, due to shadows, and also trajectory fragmentation and short trajectories. So after that, this data was divided into 2 data groups with and without shuttle presence. So firstly, we compare the pedestrian and bike flow data from Viscondo and Telraam. And since Telraam needs some time for calibration, so we only took the data collected during the last 2 days. And here you can see from these 2 pictures, the pedestrian and the bike flows from Viscondo are shown in blue and oranges, and the pedestrian and bike flows collected from the Telraam are indicated in purple and green. And we can see here, actually, Telraam consistently underestimated the amount of the respective flows. But we also see that the traffic peak period from these 2 tours are quite consistent. They are around 12 p.m. and 5 p.m. And they correspond to the lunchtime and the last lecture given at the university. So in addition, shuttle data from Viscondo and Telraam was also compared according to the 2 plots. On the right-hand side, we can see that Telraam overestimated the traffic volume by more than doubled during some of the hours. It seems that Telraam cannot properly deal with traffic counting where road users share more or less road space together. Although most users move in clear direction, that is from north to south and from south to north in our case. So generally speaking, the Viscondo system is a more sophisticated system than the Telraam. So actually it is not surprised that it gives a better sense about the traffic volumes in the study area. But such high deviation was not actually expected from us. And since the Viscondo's shuttle counts are closer to the ground truth, so we could assume that Viscondo's pedestrian and bicycle counts are also closer to the ground truth than the Telraam counter. And further on, we compared the Viscondo's shuttle flow data to the real shuttle counts. And here we can see that the picture on the bottom, you can see that actually Viscondo data also contains some errors here, and it shows that Viscondo tended to underestimate the amount of shuttles. Of course, it is dependent from the weather, from the sunshine, especially the location is in Sweden. So the weather is quite various. Yeah. So to the next slide, what I have is based on the Viscondo data, we firstly look at the space usage situation of the road users. From the right picture here, we can see that the automatic shuttles ran only from north to south as wished, and mostly on the bike path, which locates in the middle of the space. And the cyclists in both directions mainly use the bike paths, but the northbound traffic cyclists tended more often to use the sidewalks here. And regarding the pedestrian, we can see that only fewer pedestrians used and crossed the bike path. So from this table on the left side, we can see that automated shuttle around 99.5% on the bike path as wished, as expected. And when no automated shuttles appeared, so around 2/3 of bicycle trajectories were in the bike path area. And there was a reduction by 20% when the shuttles were present. So regarding pedestrians, here we can see that actually only 7% of the pedestrian trajectories were in the bike path area, and this percentage decreased to 5% when the shuttles appeared. So to the speed and acceleration, here we can see that the analysis result shows the shuttle ran actually with a mean speed 2.1 meter per second. So it is around 7.5 kilometer per hour in this study area, and which is almost only the half of the maximum allowed speed. So the shuttles went really, really slowly. And the pictures on the right-hand side shows the distribution of the bike mean speeds. The upper one is in the southbound direction, and the bottom one is in the northbound direction, with and without the shuttle presence. So we can see when the shuttles appeared, there was a decrease in the bike mean speed in both directions. So the corresponding standard deviations are quite large. Therefore, these speed changes are not statistically significant according to the t-test result. And regarding pedestrian, it seems that pedestrian tend to walk faster when the shuttles appear. So it could be due to the pedestrians got a feeling of urgency when the shuttles were there. But we also noticed that fewer crossings were made by the pedestrians when the shuttle were there. So it could also be that the speed for street walking were faster than those of crossing. But in any case, we think deep investigations are needed for understanding the unexpected result. So regarding the acceleration, actually the mean acceleration of all road users were close to zero, with or without shuttle presence. And here, this picture shows an overview about the distribution of speed and acceleration per user type and per direction. We can see that actually shuttles' speed and acceleration spectra largely overlapped with the pedestrians. So the speed spectrum was between 0 and 3 meters per second, and the acceleration spectrum was mainly between -1 and 1 meter per square second, which is actually the comfort in the comfort area. So it could be imagined that a group of pedestrians could be classified as a shuttle sometimes due to these characters. And in comparison to that, bikes spectrum is relatively wide. It is between 0 and 6 meters per second for both directions. So regarding lateral position, the distribution of the bike lateral positions in relation to the predefined shuttle position, that it is x equals to 0 in both directions, are indicated in these two pictures on the right-hand side. And we can see that a portion of bike traffic shift to the east of the shuttles in both directions when the shuttle were present. And it also shows that the southbound bicycles tended to reach into the pedestrian area more than the southbound bicycles. So in contrast, we can see that pedestrians still mostly use the sidewalks when the shuttles were there, and some pedestrian activities happened on the bicycle paths as well. And we can see that there's a slight increase to choose the pedestrian path and to use the interior sidewalk when shuttles appeared. So besides, we further checked the intersection between bikes and shuttles. Actually, we cannot observe them from the trajectory data. We can only see the maneuvers from cyclists intending to take. And what we find is also only the respective action points, not the decision points. And here we identified two main maneuvers. And the first one is the overtaking maneuver that happens in the shuttle running direction. Here you can see a diagram, time-space diagram example of a shuttle and a bike here. So the x-axis is the time, and the dashed lines indicate a shuttle positions where the thick one is the x position and the thin one is the shuttle's y position. And the solid lines represents a bike's positions. And the thick one is the bike's x position, and the thin one is the bike's y position. So we can see that the bike began his overtaking maneuver from the left-hand side here. And then when it reached the shuttle y positions, it begins to move back to the path, to the bike path. And
one more minute, please.
Oh, really? Oh. So the duration of what we analyze is the average duration is like 8 to 10 seconds, and the average speed difference is 3 meters per second when two objects were at the same y position. And here again, the second identified interaction is the maneuver for conflict avoidance. Here we can see that actually this interaction happened due to the northbound cyclists share the bike path with the southbound shuttles. So when a cyclist is coming toward to a shuttle, he or she here moved out from the bike path, and then after passing the shuttle, he or she begins to move back to the bike path. And here we divided the overall duration to the duration TC and TD. And in several cases, it cannot be divided due to the camera coverage area is limited. And sometimes it is also because perhaps the bikes didn't tend to move back to the bike path. But we cannot, because we don't have the information, so we can not check it. So again, the derived average duration is between 9 to 13 seconds. And the average speed difference is 1.5 meters per second when these two objects were at the same y position. So my last slide to conclusion and next step, actually the data is actually where unavoidable contains discrepancies here. Sorry. And there's no actually exception for video-based trajectories and counts. So the analysis result shows that the crux issue of video-based data collected by Telraam and Linköping. So Telraam seems has the difficulty to count and classify traffic correctly in an area where roads more or less share the space, and Linköping data is close to the ground truth. Then Telraam, but it still contains errors. So as a result, it shows that the introduction of the shuttles mainly has an impact on cyclists, and some of them tended to breach into the sidewalks. And actually, we didn't find any significant conflicts between pedestrian and bikes. And we think it is probably due to the lower amount of road users resulted from the COVID-19 pandemic, although the COVID-related policies in Sweden were actually more open than other countries, so more investigation would be needed. And the next step, what we have is to try to apply the derived information for enhancing, if possible, the bike modeling in the simulation, and try to find a proper parameter set. So thank you very much for listening, and I'm happy to answer questions.